plastics part production. My name is Sri Krishna S. Chittor. I'm also known as SimK in TriMech circles, since I'm one of the simulation product specialists here at TriMech Solutions. In order to access the audio portion of this webcast, you can refer to the webcast info screens, wherein you would see my details at the very top and the info on the webinar right below it. You can type in your questions at any time during the webinar, and I'd be more than happy to answer them at the very end. As Dana mentioned, TriMech Solution offers sales, support, and training for products such as SolidWorks CAD, simulation, electrical, composer, and EPDM products offered under the SolidWorks umbrella. We also provide contract services in the same area. With that said, let's go ahead and get started with the overview of SolidWorks simulation family. So before I jump into plastics, I thought it probably might make sense for you to take a 30,000-foot view of the simulation products or design validation products offered by SolidWorks. On the very top, you can see SolidWorks Simulation, which is a mechanical design validation tool. Helps us in figuring out failures of structures due to stresses, excessive deformations, and factor of safeties. And then we have SolidWorks Motion, which is a physics-based motion simulation tool. Allows us to simulate the moving components and facilitates the design of motors, actuators, gears, and cams. It can also help reverse engineer and perform interference checks. At the very bottom, you can see SolidWorks Flow, which is a full-fledged computational fluid dynamics software offered by SolidWorks. Helps to study the flow of any kind of fluid inside or outside the product. A good example would be pumps, valves, electronic enclosures, etc. And today we are going to focus on SolidWorks Plastics, which is a injection molding software analysis provided by SolidWorks Simulation Portfolio. Because plastics are everywhere, I mean, wherever you are, you may notice that almost all the plastic parts around you are manufactured using the injection molding process, which I believe is probably one of the most common processes used in manufacturing molded plastic parts. And large companies such as Foxconn heavily rely on injection molding to bring their products and their different product portfolios to the customers faster than most of their competition does. All or most of the players in the plastics industry care about these issues in the company. Are the parts manufacturable? What would be the best gate location? How could we identify weld lines or air traps? What would be the cost of these changes? And so many questions like this. And these players each have their own objectives and responsibilities, and also have common challenges in terms of quality, cost, time optimization, and their overall willingness to innovate. Design simulation tools can heavily impact the efficiency and productivity of the entire team to make a positive change or positive progress in the development of the plastic product. Let's go ahead and review how design simulation helps answering these challenges. When we take a look at the injection molding design to manufacturing process, historically it's been people downstream in the manufacturing environments that have been tasked with making sure parts meet manufacturability, quality, and launch requirements. In other words, part designers have not had a significant influence on the manufacturability of their designs because it's often someone downstream that's responsible for running different types of analysis to determine whether or not a part design can be easily manufactured. In fact, a very common worst case scenario still seen today is simulation not being used until manufacturing defects are discovered. A single simulation analyst troubleshoots the problem and determines a solution given existing constraints. For example, the part is fixed, the mold design might be fixed, the material cannot be changed, etc. Of course, even if the analyst is successful, valuable time and material are being wasted, driving up costs and eventually pushing out product launch dates. The second method, or the next logical step, is to validate existing part or mold designs to ensure manufacturability and avoid the time-consuming and costly production delays. While the results in more value realized from the use of simulation, there's still the potential for significant hidden costs because parts and molds are not being optimized. For example, without optimization, most of the companies are not determining if the parts could be made thinner by reducing the material usage. Can one decrease cycle times, using less energy, or lowering the overall cost? This is what SOLIDWORKS recommends as a preferred way. So today, world-class companies are using this type of simulation process in the earliest stage of the part and mold design, allowing more users to optimize more designs. So regardless of what phase of the process a product development team member is involved in, they can take advantage of simulation to ensure that their part design or their mold design eliminate costly mold rework, overall improving the quality of the part and decreasing the time to market. And the value proposition is pretty simple and straightforward. 80% of plastic parts are injection molded. The process is a very complex mix of time, temperature, pressure, material, and variables. Injection molds can range in cost from tens of thousands to hundreds of thousands to over $1 million, meaning mistakes could be very expensive and time consuming when we talk about injection molding. Great thing about SOLIDWORKS Plastics is that using it on just one project can just justify the cost of the software. So now let's go ahead and try to answer the big picture or the $1 million question as to why one would want to use SOLIDWORKS Plastics in their injection molding process. The first and foremost important reason being that SOLIDWORKS Plastics can help you get a window into your mold, which means the user gets to experience a full 3D visualization of the melted plastic flowing through the cavity, which is being simulated by SOLIDWORKS Plastics. The second key benefit, or the second key usage of SOLIDWORKS Plastics, is the user gets to evaluate multiple design scenarios or explore design variants at the design stage, as opposed to the old-fashioned way where the user had to wait till the results from the analyst would come back and then redesign the products. So you can simultaneously make design changes and run simulations to answer a good bunch of what-if scenario questions. Multiple cavities or family molds could also be simulated in SOLIDWORKS Plastics. And last but not the least, the capability of modeling cooling channels and visualizing the warpage parameters in the plastic parts makes SolidWorks Plastics a really, really powerful tool for the injection molding process. All right, let's go ahead and take a look at these individual key capabilities offered by SolidWorks Plastics. When we talk about getting a window into the mold, you're trying to answer questions associated with key manufacturability issues. Questions such as, will the part fill? What would be the optimum thickness associated with the wall? Where would the weld lines be or knit lines be? And how would that affect the functionality of the part? The user also gets to answer questions such as where the air traps would be located, which means that helps the user identify the tooling required to accomplish that process. And at the end, you can also answer questions such as how much cooling time or pressure is required, and helps you kind of estimate the overall cycle time associated with the process. So here is a good example of the simulation workflow offered by SolidWorks Plastics. So the user brings in a geometry from the SolidWorks CAD model, and the best part about plastics is that it's completely integrated with the CAD interface of SolidWorks. In the conventional simulation process, one would design their product using a 3D CAD modeling software like SolidWorks, and then export the geometry as a step file or a STL file into a meshing software, and then create a mesh to represent the geometry, and then export the meshing file into a solver where one would set up these kinds of simulation. But all these hassle of exporting different files and having disconnected softwares is taken care of by SolidWorks by just integrating the CAD model with the solver, which means as and when you make changes to your design, you can go back to your simulation setup in plastics and just update and run your models, and cut down a lot of wastage in the time that goes through the conventional process. So in the first step, one would start with the mesh, and SolidWorks offers auto refinement and auto meshing capabilities just to speed up the process. As mentioned earlier, SolidWorks Plastics is more of a designer-friendly tool, so it helps a designer to set up a simulation quickly and not take days together, and run the solution and go back and make design changes back and forth in the early stages of the design. Once the mesh is set up, the user goes through a series of setup processes, such as defining material properties. For example, you pick a plastic part, define ABS or some of the PP kind of materials, and then you specify the injection location just by clicking on a specific graphics area within the part. And then you hit the solve button. We are actually going to see a live demo of the software after I finish the next couple of slides. Once you do run the solver, you actually get real-time feedback of different types of results associated with plastic simulation. It could be fill time, it could be temperature at the end of the fill, it could be pressure, and so on and so forth. So after you finish running the simulation, you can actually animate and visualize different types of results, which helps you in the post-processing phase to identify the key aspects of the design and help making key design changes based on these results. The plot that you're seeing is the fill time plot for this part, showing that it takes roughly about 2.3 seconds for this part to fill up. You can also get some really detailed information on weld lines or knit lines and air trap locations, which helps you make suitable design changes in order to improve the overall quality of a plastic part being designed. So plastic simulation is not just about the ease of use in SolidWorks, but it's also about getting the right kind of information in faster time at really accurate levels. So once you finish the post-processing phase, you would review all the results and make a suitable design change. One of the neat things that I really like about SolidWorks Plastics is its ease of use. Just like the SolidWorks CAD tool, you've got some really cool tools such as Wizard, which helps the user set up a analysis in a couple of minutes to 5 minutes, and then run a quick fill time study. This also comes with a result wizard, which helps the user to interpret the results being shown or interpret the plots being shown in the CAD window. All right, with that said, let's go ahead and take a quick peek at SolidWorks Plastics. I've got a really simple looking plastic part here. The cool part about plastics is it assumes the part as the cavity when you get into plastic simulation mode. You may notice that just like you have your SolidWorks CAD interface with Command Manager on the top, feature tree on your left, you have a very similar interface for plastics. You're just switching tabs to switch from design mode to simulation mode. In here, as mentioned earlier, the user can specify different parameters associated with the plastic by using this wizard, wherein you start with a unit system and then progress by defining the mesh and define a material property. SolidWorks Plastics offers a pretty detailed material database having 4,000 plus materials organized based on family or based on company which manufactures these different materials. The user also gets a quick feedback on the key properties associated with the material data being applied on the part that's being analyzed. And as you can see on the very top of this wizard, it shows a progress or a status of the simulation setup. The user has access to every single key parameter or key boundary condition being set up in order to simulate the filling of the part under concern. So as you can see on my left, I'm able to define different fill parameters, be it fill time or mold temperature, or the limit for the injection pressure, which is dictated by the machine. And as far as injection location is concerned, you can add the injection location by clicking on the surface of the part or clicking on the volume of the part in your graphics area. So these are nice little things that makes SolidWorks easy to set up and run as far as plastics is concerned. And when we talk about results, it comes with a really cool post-processing tool where one can look at and animate different types of plots, look up options such as weld lines, wherein two flow fronts meet. One can look up locations of air traps. Obviously, in this case, if I animate my fill plot, you can clearly see that it's creating two air traps on those two locations being shown. As I was mentioning earlier, what's nice about SolidWorks is they offer different types of wizards or advisors for the user to understand what they're doing. This is one of the really cool wizard which basically explains the parameter that's being shown on the screen and gives a nice red, yellow, or green check mark, letting the user know whether this part is going to fill successfully or if there are going to be any issues. All right, with that said, let's go back to the slides real quick. So what you saw was that the user can actually get a window into the mold or get a full 3D visualization of what's happening inside the mold cavity, which helps identify the manufacturing issues and defects up front as opposed to the conventional process of waiting till something goes wrong. Next, we're going to talk about what-if scenarios, wherein the user gets to answer different types of questions, whether the sink marks are large or should the injection pressure be reduced, or should a different gate location be tried. Basically, one can evaluate different effects of different parameters on the overall quality of the product. Questions like, hey, what's going to happen if I increase the wall thickness? Questions like, how do I decrease my flow length in the simulation, and what's the optimal or ideal flow length? And all these questions are answered just by going back to the model and changing one or two different things, as opposed to setting up the entire study or setting up the entire project every single time. All right. With that said, the ability to evaluate multiple what-if scenarios helps the user to reduce or fix the errors up front. And talking about multiple cavity or family molds, the user can actually model different types of runners and sprues, depending on the type of geometry that's being used to model these runners. There are some inbuilt layouts for designing the sprue and runner or gate layouts, which helps the user to basically speed up the process. The user actually just have to create a sketch that represents this layout and can define that sketch as a gate or a sprue or a combination of both. The SolidWorks Plastics tool also offers the ability to balance the runner design. So the user specifies a baseline or a basic runner definition, and the solver has the ability to kind of optimize the different geometries associated with gates, runners, and sprues using the runner balancing wizard. So that basically helps you set up a detailed simulation with the same workflow optimization capabilities. Last but not the least, one of the winning features of SolidWorks Plastics is the ability to model cooling and warpage scenarios within the plastic simulation. The causes of injection molded plastic part warpage could be either non-uniform shrinkage or differential molded in stress, or non-uniform cooling rates, molecular and fiber orientations, or even variable packing. One can investigate all these different causes with the power of warpage analysis capability within SolidWorks Plastics, and optimize the overall stresses or warpage within the part by using the warpage capabilities. One can avoid the injection molded plastic part warpage by maintaining uniform wall thickness, trying to achieve uniform fill patterns, pressure distributions, and temperature distributions, or trying to achieve uniform shear stress distributions in volumetric shrinkage. Most important of all, maintaining uniform cooling rates. One can design and analyze mold cooling line layouts, optimized cooling system, designed to minimize cycle times and substantially reduce the overall manufacturing costs using the cooling module that's provided inside SolidWorks simulation. At this point, I'm going to quickly stop and check if anybody has any questions so far. Dana, can you hear me?
Yeah, there's no questions as of right now.
All right.
So you can go ahead and keep on going.
Excellent. So with the plastics cooling tool, one can model and analyze different types of baffles, bubblers, and mold inserts. One can also look up the temperatures along different cooling lines, which are again modeled just by using the sketches created in SolidWorks, which is a pretty neat feature in the cooling module. So cooling line optimization and warpage analysis basically optimizes the overall cycle time, which is a big chunk associated with the cost of the product as well as time to market, and it ensures the manufacturing tolerances at the same time. So these are the key benefits associated with the plastics product offered by SolidWorks Simulation. As far as the value associated with the tool is concerned, we get the overall communication with the mold manufacturers being streamlined, and we get to reduce the expensive mold rework and hence decrease the time to market and cut down the cycle times and reduce the machine downtimes. And at the end of the day, what matters the most is the quality of the product, which is certainly going to be improved with the help of a tool like SolidWorks Plastics.
Krishna, real quick, I can't see your screen, just so you know.
All right. All right, can everybody see the screen?
Perfect. Thank you.
All right, thanks for that.
Mm-hmm.
With that said, let's go ahead and take a look at different packages offered under SolidWorks Plastics portfolio. We've got Plastic Standard, which is associated with fill analysis, gives the user the ability to look up the fill times, knit lines, sink marks, air traps, simulate multiple gates. The next level up is Plastics Professional, which has all the filling capabilities offered in Plastic Standard, plus the ability to model the packing scenario. Also, it offers some really cool tools such as runner balancing and being able to simulate insert or molds and multiple cavities and so on and so forth. The topmost tier in the plastics family is Plastics Premium, which offers all the capabilities presented in Plastic Standard and Professional, in addition to the Warpage analysis and advanced cooling module. With that said, I'm going to go ahead and wrap up my presentation. I thank you all for your time, and I think I'm ready to take some questions.
All right. Are there any questions out there? Oh, wait, just a couple minutes here to see what comes in. Just so you know that This webinar is available on our YouTube channel. You can access that through our webpage at trimech.com. You will see it on the upper right-hand corner there with our Facebook, Twitter, LinkedIn, and then you'll also see our YouTube link there as well. So this webinar and all of our other webinars are available. All right, well, it doesn't look like there are any questions at this time, so I just would like to thank you all again for joining us this afternoon, and I hope you have a great rest of your day. Bye-bye.